Hello, grade 11 class. This is Monday, November 7th, and we are looking at probability lesson 2. So our test is hopefully going to be next Monday or Tuesday, so the 14th or 15th, but we will see as we go. All right, so the first thing to jump into, we're going to see which one doesn't belong. So go ahead and let me know, which one do you think doesn't belong? And as we know here, really, you can argue any of them that don't belong, but we're going to be looking at cards today, dice today, and a whole bunch of different probability objects that we can use to find different probabilities. All right, so looking back at lesson one we talked all about experimental. So we did, do you remember that experiment where you had the 3 coins and you flip them in order to get points? So it's all through an experiment. So experimental probability is, and you should have this sheet in front of you as well. I handed them out all last week. If you don't have it and you didn't get it, you can always download it right here as a PDF or a Word. So experimental probability. And if you missed experimental probability, you can go on to the OneNote and see the lesson right here under experimental probability lesson 1. All right, so experimental probability is all about the number of successes over your number of trials. So number of success. So that would be like the success of rolling a 6 for one dice, or the success of rolling snake eyes, right, with two dice. So that would be like rolling 2 1 over your total trials. So here you could roll it so many times and get no successes. That trials is totaling up, right? You can roll 2 dice, like 20 times, and then only get snake eyes once. So 2 ones, 1. All right. But theoretical probability is the measure of the likelihood of the event actually occurring. So without performing it, what's the probability of this measurement? What's this possible? What are the possible probabilities of like rolling a 2 out of 6, right? That'd be 1 out of 6 times. All right, so for our theoretical probability formula is, again, we have to put P of the event. So the event would be like rolling a 2 is equal to your number of successful outcomes divided by the number of possible outcomes. Possible. So this is not trials anymore. It's how many outcomes there should be. We're not doing trials anymore. So to calculate the theoretical probability, all outcomes must be equally likely. So there's no loaded die or happening here. So meaning that every event has the same chance of occurring, and the conditions are fair. Again, the probability of event is a value between, do you remember what numbers it's in between? It's between 0 and 1. So we're dealing with a lot of decimals and fractions here. So we're having a lot of fractions. It must be a fraction. All right, so for our coin flipping experiment, we can also use a tree diagram. So this is what a tree diagram is, and here's like all the little branches that are happening here. And what are the 2 outcomes for flipping a coin? Well, for flipping one coin, you can get heads and tails, right? So you flipped a coin, you get heads or tails. And then the next, it wouldn't be like, this would be like your next one. What could you get? So you could get, if you flipped heads, then you could get heads again, right? So your next flip, you could do heads and then heads, but you can also do heads and then maybe tails. So we go down like this branch. Or if your first flip, you flipped a tail, well, for first flip, you flipped a tail, then you can also get heads on your second flip. You can also get two tails, right? Tail and a tail. So your first coin flip, you can get heads, heads, and then let's say you flipped it again. You could also get heads again. Or you can get heads, heads, and then maybe tails. And hopefully you're starting to see kind of like how this tree diagram is created. Well, we can see that there are going to be, and let's look at them all, 8 possible outcomes for these specific events. Like, what's one possible outcome? So one possible outcome is you can flip it heads first, and then second, and then third. You can get 3 H's. So H, H, H. Right, 3 heads. All right, and then 2, you could also get, maybe I'll just leave the highlighter. You could get heads, heads, and then tails. So we'd have H, H, and T. You can also get H, T, H. We're looking at all the different ones, H, T, and T. Okay, so those are all the ones that's starting with H. Now let's look at all the ones starting with T, tails. So for tails, we can do tails, heads, heads. We can look at tails and then heads and then tails. We can get tails, tails, heads. And the last one, tails, tails, tails. All right, so there's 8 possible branches that are happening here. Okay, so what about our event when we were flipping a coin? So what was that, on Thursday when we were flipping coins? The event of earning 3 points was flipping, I think it was heads 3 times. And how many times can you get heads, heads, heads on each coin? Well, you can only get that possible outcome happening 1 out of 8 times. That's 1 out of 8 times. What about the event of earning 1 point? The event of earning 1 point was getting, or sorry, tails. I think it was all tails. So the event of earning 3 points was tails 3 times. And then getting 1 point, you had to get 2 tails. Okay, so let's go look at all the events of getting 2 tails. Okay, so that's heads, heads, tails. No, what about heads? No, here, that's 1, 2, 3. You can get that 3 times. Here was that tails 3 times is 1 out of 8 chances because there's only 1 of them. But getting tails 2 times is how many chances? 3 out of 8. There's 3 out of 8 getting tails 2 times. All right, so you get 3 chances. And then lastly, what about earning no points? So not getting any points at all. So getting no points at all was 1 tail or no tails. 1 or no tails. So 1 or no tails, that's 1, 2, 3, 4. So that's 4 out of 8 or 50%. 50%, it's 1/2. So listing the outcomes and the events given gives you a more clear indication of the chances of getting a particular event or a particular event occur. In this case, you can calculate the theoretical probability for each event. Okay, so probability event A. Event A was we were going to get tails 3 times. What was that? The probability, that's your number of success over your number of outcomes, which is 1 out of 8. Or you can calculate this to be 1 divided by 8 is 0.125. Right, again, we're seeing that we have fractions here. There's no whole numbers. What about the possibility of getting 2 tails 2 times? And this is, you flipped it 3 times and you get 2 tails. So like you flip it and you get 2 tails. So again, your number of success over your number of outcomes, we get 3 out of 8, which is 0.375. And what about our last one was tails 1 or no times. And this would be 4 out of 8, which is 1 over 2, which is also 0.5. So we can look at it in terms of fractions as well as looking at it in terms of decimals. What about even percentages? What's this percent? This is 125%? No. This is 12.5%. How did you figure that out? You multiply it by 100. Same with this one. 37.5%. And lastly, 50%. So we can also look at them in terms of percentages. And throughout these videos, you can pause it at any time. So you just go and press pause. You can rewind, fast forward at any time. You can also watch these videos at any time as well. All right, a standard deck of playing cards has 52 cards, 13 of each suit. All right, so we have how many cards? There's 52 cards, and there's 13 of each suit. Well, we actually have 4 suits, right? There's 13 of each suit. There's 4 suits. We have hearts, we have diamonds, we have clubs, and we have the spade, right? Hearts and diamonds are red, and clubs and spades are black. All right, so let's look at the probability of drawing a heart. So P of heart is equal to, well, we want the number of hearts divided by all the number of possible outcomes. All right, so how many hearts are there in a deck of cards? There's 13 hearts. And how many cards are there? There's 52. So that's it. It's going to be 13 out of 52, which is 1 out of 4. An ace. So what's the probability of drawing an ace? So we need the number of aces divided by your number of possible outcomes. And how many aces are in a deck? There are 4 of them. And how many cards are there? There's 52. All right, and this can be reduced to 1 out of 13. All right. What about the outcome of getting a heart, a club, or a jack? So we want the probability of obtaining a heart, a club, which looks like this, or a jack. Okay, so here, how many hearts are there? Well, there's 13 hearts, right? So that's like the first one. So how many hearts are there? There's 13 hearts. How many clubs are there? How many clubs are there? There's 13 as well. And then how many jacks do we have? Well, we do have 4 jacks. However, did we just count some jacks in here in hearts and clubs? Absolutely. So we really got to be careful here. You can't double count. It's not going to be 4. Can you kind of give a good guess as to what it's going to be? 2. That's it. Why is it 2? Because we don't want to count it twice. There's already a jack in here in 13, a jack in here for a club, and then so we're only going to have 2 left over. So be careful not to count jacks twice. Careful not to count jacks twice. Because we already counted them in terms of, we already have the hearts and we already have the clubs, right? They're already in. And then what are we going to divide this by? We're going to divide this all by 52. All right, so let's add it up. So 13, 13, and 2 gives us 28 out of 52, and those are both even, so those can reduce. That reduces to 7 over 13. Right, and then one more. What's the probability of getting a heart, a club, a spade? Oh, messed that one up.